Okay, welcome. We are going to start our last learning target in this unit. We are going to be able to graph radical functions. Our focus is going to be pretty much on the square root function. This is section 6.8 in your textbook. It's on page 414, and we're going to be able to take a look at functions, radical functions, and be able to graph them. This is y equals the square root of x, and we're going to graph this later, so don't worry about getting this down. You're going to get it down in a couple minutes. So let's jump in. Let's get some basics down. When we talk about graphing radical functions, we are going to write them in this form. We want them to be in the form of a times the radical, and under the rad is x minus h plus k. The h and the k should sound familiar to you. I hope you're thinking the vertex of a parabola. When we graph radical functions, if you look down here, here's the graph of the square root of x. The domain, the x values that I can plug in to the square root of x, they're all positive because the square root of negative numbers is undefined. So if you look at the domain of my x values, or the domain of this function, I'm only putting in positive x values. This is the graph of the parent function. Every radical is related to the square root of x. Here's the graph of the square root of x, and I want to talk a little bit about this a, h, and k. If there's a number in front of the rad, this a can flip the graph, and it can stretch it or shrink it. Depending on if a is 2 or 3, it's going to make it bigger. If a is 1/2 or 1/3, it's going to shrink those values down. So that's what a does. H is this number. H is my liar. Okay, guys, remember H is a liar. H moves my starting point of my graph left or right. That is my horizontal movement, is left or right. And then, whoops, I didn't mean to do that. Let's bring this back. Okay, sorry guys. My last one is K. Just like in vertex form of a parabola, K is my elevator. K is my vertical shift. So it moves things up or down. Up if positive, down if negative. All right, let's take a look at these two functions that I have down here, and let's figure out the value of a, h, and k. A here, there's no number, so a is the number 1. What is my value of h? Well, remember, h is a liar. H is a liar. So he's really the number 2. He's -2 under the radical, but he's 2 outside the radical. What's my value of k? There's nothing there. So k is 0, and the starting point of this function, my starting point is going to be h comma k, which is really going to be 2 comma 0. All right, let's do that same thing down here. What's my value of a here? My value of a here is the number 2. What is my value of h? Well, remember, h is a liar. If he's negative here, he's positive on the outside. And then let's go pick up my value of k. K is this number right here. So k is a positive 1. So if we put this together, what is my starting point? My starting point for this radical function is h comma k, which is the point 3 comma 1. Okay? All right, that's that for the basics. Let's start graphing. We're going to start by graphing the square root of x. So I'm going to create a list of values, and what I want to be conscious of, I'm going to write the square root of x over here, y equals the square root of x. I can pick any x values I want to put into this function. I can pick 1, 2, 3, 4, 5. Do I want to take the square root of 3 though? Do I want to take the square root of 5? I don't. I want to use perfect squares to be underneath this radical. So any x value that I pick, I want it to be a perfect square. So I'm going to list my perfect squares right now. 0, 1, 4, 9, 4, 9, 25, and 36. That's what I want to use. So I can see I'm not going to be able to graph that many of them right here. All right, to start, A, the value of A is 1. The value of H in my function is 0. The value of K in my function is also 0. K is also 0. I can write this as y is equal to the square root of x minus 0 plus 0. So my starting point is always the first line in my graph. And when x is 0, y is 0. And now remember, I wanted to pick specific perfect squares. I want to have this look really easy for me to calculate. So I'm going to pick really nice numbers. So I'm going to let x is 1 because 1's a perfect square. What is the square root of 1? It's 1. So I'm going to go graph 1, 1. Now the next value for x that I want to use 4 because 4 is a perfect square. What's the square root of 4? It's 2. So I'm going to plot 4 on the x, 1, 2, 3, 4, 2 on the y. The next x value that I'm going to use is I'm going to use this perfect square of 9. So when x is 9, the square root of 9 is 3. So I'm going to go all the way out here to x is 9, and I'm going to get 3. And I'm going to run off my graph for the other ones. When x is 25, y is 5. Oh, I missed 16. And when I missed 16 in there, whoops. And when x is 36, y is 6. But I don't have enough room on my graph. So what's important is when you graph this, you make a smooth curve. So try to make that as smooth as you can. And that's our graph of y equals f of x. F of x is the square root of x. All right, let's start moving into Algebra 2. We are going to graph y equals the square root of x plus 2. So if y equals the square root of x plus 2, what I'm going to do is I'm going to look for my a is 1. My h, there's nothing underneath the radical here, so that's 0. And my k is 2. So my starting point is going to be 0, 2. So my starting point is 0, 2. I'm going to go graph 0 on the x, 2 on the y, right there. That's my starting point, 0, 2. Now remember, I want all perfect squares to be underneath this radical, and since I'm not adding or subtracting anything under the rad, this is going to be pretty easy. I'm going to go and put my list of perfect squares in for x. I'm going to use 1. I'm going to use 4. I'm going to use 9. I'm going to use 16, and I'm going to use 25. So I don't want to forget my 16 because I forgot them before. All right. So this column of perfect squares I filled in for x. So let me just rewrite that. 16, 25. So what I'm going to do now is I'm going to evaluate this function when x is 1. So what is the square root of 1 plus 2? Well, the square root of 1 is 1. So 1 plus 2 is 3. So when x is 1, y is 3. So when x is 1, y is 3, right there. Now I'm going to go use an x value of 4. What is the square root of 4 plus 2? Well, we've got 2 plus 2, which equals 4. So I'm going to go over here to 2, and I'm going to plot something at 4. Now I'm going to go use my next perfect square. I'm going to use 9, and I'm going to take the square root of 9 plus 2. Well, that's just 3 plus 2, which equals 5. So I'm going to go over here to 9. Ooh, did you guys see I made a mistake on my graphing? So when, I hope you're yelling at me. Janelle, I hope you're yelling at me too. Jackie, I know you are. So I've got 1 and, oh, let me go erase that. There we go. Okay, 0, when x is 0, y is 2. When x is 1, y is 3. Let me go put my 1 and my 3 back because that was okay. Let me go plot my 4, 4. 1, 2, 3, 4, 4 is right there. Now let me go plot my 9, 5. 9 is all the way out here. 1, 2, 3, 4, 5. There's my 9, 5. And it's going to be a little hard. I'm not going to be able to plot 16. I'm not going to be able to plot 16 or 25. But I'm going to figure it out because we're here. So what's the square root of 16 plus 2? That is 4. Which equals 6. And then I'm going to go ahead and do the square root of 25 plus 2. Well, that is equal to 5 plus 2, which is 7. So let me go over here and, oh, my cursor, there we go. Let me use my blue pen. And I'm going to connect all those points. Okay? I can't see where my, there it is. It should be like that. And that's the graph of the square root of x plus 2. It looks just like the square root of x, but every point is just shifted up 2 units. All right, let's go try another one. We're going to do both a horizontal and a vertical shift. This is where this column is going to become really, really important to us. Okay, we're going to use this column of our perfect squares to help us figure out what x value to use. You'll see it as we do it. Okay, first things first. My A is 1. My H is, what's the opposite of a positive 5? It's a negative 5. My K is 2. So my starting point, you guys, my starting point is going to be negative 5, 2. So I'm going to go 1, 2, 3, 4, 5, up 2. There's negative 5, 2. All right. Let's think about this. Let's take a look at what that is. What is the square root of negative 5 plus 5 plus 2? Well, that's 0. 0 plus 2 is 2. So that's where that comes from. Now remember, I want to put perfect squares. I can take the square root of perfect squares. My perfect squares I want to use 0, and I want to use 4, and I want to use 9, and I want to use 16, and I'm going to try to use 25. So what I want is I want this expression underneath the radical. I want that to turn into my perfect square. Let me show you what I mean. I want, this should be the number 1 here, guys. We already did 0. I'm getting ahead of myself. So I want this to be the number 1. So I want to end up with the number 1 underneath my radical. So I am going to take x plus 5, and I'm going to set it equal to 1, and I'm going to solve for x. So if I solve for x here, x is going to be equal to a -4. So that's what I'm going to use. One of my inputs is going to be -4. All right, let's go see what that does for us, okay? You're going to see why I'm doing this right now. If x is -4, y is equal to the square root of -4 plus 5 plus 2. Well, this becomes the square root of 1 plus 2, which equals 1 plus 2, which is 3. So when x is -4, I have a y value of positive 3. I have a y value of positive 3. So that's 2. It's that guy right there. All right. This is my calculation area. We're going to go back, and what I want underneath the radical, I want x plus 5 to equal 4. That's what I want. I want a perfect square underneath my radical. So that happens, whoops, when x is equal to a -1. So I'm going to put a -1 here, and now we're going to go calculate this out. What is the square root of -1 plus 5 plus 2? This is going to be, the square root of 4 plus 2, which is 2 plus 2, which equals 4. So now I'm going to go to -1 on my x and 4 on my y. So do you see how I'm not getting any decimals for my output? I'm not getting any decimals for my output. And my calculations are really easy because I'm forcing a perfect square underneath my radical. All right, I want underneath my radical to be 9. So when does x plus 5 equal 9? It equals 9 when x is equal to 4. So I'm going to put a 4 here. And now I'm going to go compute. What is the square root of 4 plus 5 plus 2? What is the square root of 9 plus 2? This is 3 plus 2, so I end up with 5. So when x is 4, 1, 2, 3, 4, y is 5. And I think we can do one more, and we'll have the 5 points that I'd like us to plot. So let's take a look at the last one. I want under my rad to be 16, so x plus 5 has to be 16. So x is going to be 11. I'm going to end off a hair off my graph over here, but we can do it. All right, let's put in the square root of 11 plus 5 plus 2. This is the square root of 16 plus 2. So 4 plus 2 gives me 6. So I'm going to go all the way out here to 11, go up to 6. And here is the graph of this radical function. What we notice is its x values are shifted to the left. Remember our original square root function, y equals the square root of x? It was this guy. This is my original square root of x. Well, this function has been shifted to the left. How many units? 5 units. And it's been shifted up. It's been translated up by 2 from our parent function. Okay? All right? I think we're good. I think this is plenty to get started on. This one we can take a look at in class. I'm going to do this one in class. I have a value of a that's going to show us what happens. So what I would like you to do for your entrance slip, be ready to graph this function, and I want you to describe its transformation from y equals the square root of x. Okay, thanks for hanging in there with me. We'll see you tomorrow.